So if someone could check.
I have it open. Right? Yeah.
Awesome. Sweet. Do you mind posting that in the?
For your tweet. Now I'm gonna post the stream.
Heck yeah.
Posted where?
We'll get started in just a second. Okay.
Is it just Wi-Fi guest?
Yeah, yes, the Wi-Fi.
One, the meeting room has a password if you want to use.
Is it on the? It's on the.
Here we
They
go.
have newer Wi-Fi standards where open networks still are encrypted. I doubt it.
I don't know.
No.
I feel like this stuff develops slowly.
I hear it working.
Good. Yeah, I just had to mute it, so. Awesome. Sweet. All right. Yo.
How's it going?
Good.
Welcome in, man. Just about to get started.
I'm glad we delayed it.
Yeah, I know, right? Let people kind of filter in. Time to chat.
Should we do a quick round of formal introductions since we all kind of been like haphazarding it real quick?
Yeah, I think so. Let's do it. Like quick rounds. What you're working on or what you're excited about. And what your name is. Okay, my name is Colin. I work on this product with Marco called Metal. Here, I'll turn on my webcam now. It's gonna be there as well as here, which will be weird. But, well, actually, maybe people don't want to dox themselves. Let's, we'll just, anyway, it's being streamed, but I can cut the stream down later, so we're good. But yeah, I'm Colin. I work on this product called Metal with Marco. It's a way to take Foundry scripts and make templates out of them so that you can point them to any network, deploy them, change the parameters. So it started off as a dev tool, and now it's like trying to be like a deployments as a service product where you hit an API route and then you get a set of exact bytecode smart contracts on the chain that you point to. So kind of we're hoping to do what Vercel did with Web 2 deployments, where they just turned, like we don't even think about deploying our servers anymore. We just do git push, right? They API-ified and sort of integrated really tightly with the dev stack. We're hoping to kind of take away some of the complexity of deployments as well. What I'm excited about recently is I am working on a project to help bring coffee farmers on chain and like some coffee commerce on chain as well, so that you can use like really cheap networks like Base to handle like normal everyday transactions like buying coffees and then send farmers USDC tips, as instead of sending 3.5% to Visa network on every transaction, you send 3.5% directly to a grower where they hold it in stable currency. That's been kind of fun lately. A merging of my two loves of like coffee and software. So yeah, I'll pass it either way.
Hey, I'm Sam. I am head of growth at Steer Protocol. Been in crypto for a while, since like 2017. I started working at a wallet company. We're an off-chain compute protocol, bridge on and off-chain data to enable robust automations on-chain and cross-chain. So we're deployed across 25 different blockchains right now. We provide, our first product was automated liquidity management product for UniV3 algebra, so concentrated liquidity AMMs, and we're working with like 30 or so AMMs across those different networks we're on, and excited about a few different upcoming releases. We've got like a new strategy, which I think we gave you guys a little insight into before that's coming online soon, and then we've got for liquidity management, and then we've got a couple of new like full new products that are going to be launching in the next couple months, which I'm really excited about.
Yes, your protocol. I was very impressed.
Yeah, our founder's I've worked with him since 2017 3 different companies, and he's very savvy, very smart, and has run into a lot of the same problems, which is why he built Steer.
Nice.
Well, I'm Marco. I work with Colin on Metal, or for Metal. I do a lot of research for it, or look at a lot of contracts and how we could integrate them into templates. And he pretty much explained the product already. I'm pretty excited about my work for East Denver as well. I'm trying to make sure that next year's hackathon and teaching curriculum will be a little bit more built out and allow for things like this over there. We have a Biddle week, so I would like to bring more people like Colin to the forefront and make sure that in the middle developers, like intermediate developers, can learn something there as well, and instead of just beginners. So yeah, that's really it.
Hey, my name's Nuke. I've been around for a while running this thing you might recognize brand-wise, Cryptorado. This is a general community of great people like yourselves who are interested in all things Web3. So I'm really excited that we're starting to really do some more interactive events and tech-focused events like today. And outside of that, I'm just starting up at a company called Risk Zero. So I've been a fan of ZK Space for a while, and now finally actually getting involved in it. So on the same mind of doing more technical workshops and stuff, I'll be doing one here in a couple of weeks around this. So if you're interested in playing around with Rust and doing something to do with making proofs, come talk to me. Otherwise, I'll show our Zulip if you're not on there for Cryptorado. Cryptorado.org has all of the events that were listed on our Luma and this chat platform Zulip, which I'm liking because it's so much less noise and it's minimalist versus like Telegram and Slack and blah, 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 blah. So come check us out there. That's me.
Thank you. So I'm Fabian. I'm a CTO at Webox in Central Tokyo. We do NFT and digital experiences for the anime industry. We have a strong tie with Japan and Hong Kong and Asia in general. And yeah, and so I'm French American, based in Denver. What I'm excited about, I would say layer 2 and anything that can onboard the next billion users. I want my mom to be able to use crypto, and right now it's hard because the rewards and random stuff, and everything is expensive, and so that's why I'm excited about layer 2s, and really excited about base, what's happening in space right now, Coinbase smart wallets and all that stuff.
Totally.
So yeah.
Just included smart ones.
So sick. Smart wallets, amazing, amazing stuff.
I'm Alex. I am head of partnerships at a Web3 marketing agency and also advising a project or two.
Are you on salary now?
It's a nuanced discussion. But
Okay.
technically.
I'm stoked that you like hang your hat somewhere.
Yeah.
Sick, dude.
Yeah. It's been good.
Good.
Hey, I'm Dave. I do protocol and backend work for EtherFi. Required by my employer to say we were hiring. Before that, I did firmware for the Kiki hardware wallet, and then a bunch of stuff for Shapeshift over the years.
Sweet.
I think oddly enough, I took my first Solidity class / meetup, and that was over there like 8 years ago or something.
No way. Solidity compiled back then? Crazy.
Yeah, I was talking to I ended up working with the instructor later, and he was like, "Oh, I learned this like 3 hours before the class."
Nice.
Hi, I'm Sian. I do some dev work for a project called Streaming Quadratic Funding. I think renaming it to Flow State Co-op, so it's going to be a co-op, so anybody can join.
Nice.
I am excited for us to launch officially, I think, at the end of summer. So,
Flow State is a sick name.
yeah.
Nice. Cool. Rock on. All right. So, I think we're ready to go. Ready to get started. All right. So, to kind of bump up the energy a little bit, because I'm post lunch as well, so I need to like get through this slog. How we like to run this meetup is like, it's an open conversation. There's no dumb question. And I'm gonna ask you guys like to hold your hand to your chest and say like fist of 5. When I say that, that means like your level of understanding. So if it makes 1 level of sense, then do this. If it makes 5 levels of sense, do this. Because it's like, if you're like, does this not make sense? No one's gonna like raise their hand. It's just like not our nature. So like we'll try to all walk through this contract at like different levels of abstraction to understand it at a high level, to understand it at a low level, and then we can. I'm gonna allot us. This is a good idea. I've never done this. You and I should do this. I'm gonna allot us 3 side quests. So we have 3
Tangent.
3 squares.
Nice.
Exactly. And so our order of operations here is going to be like high level overview. Then we're going to go through like commonly used functions. And I like to call this life cycle. And this is like, I think, a good way to understand smart contracts. And then we'll go into like technical dives. And so if you think that something is like super interesting, bring it up. I'll tell you whether or not it's a side quest. Like if you're like, hey, what is that? That's not a side quest, don't worry, right? But if it's like, hey, could we like dive into how this contract does this? Or if I'm like really explaining things at a deep level, that'll count as a side quest, and I'll say it. So I'm the keeper of the side quests, not you guys. So just like throw out any questions or any curiosities. Like my whole shtick with smart contracts is like, we need to be truthful with the software we write, right? Like bytecode executes like deterministically all the time, and if we try to put millions of dollars worth of value inside of these addresses that have bytecode, we better know exactly what that bytecode does, sometimes to the bytecode level, right? The question, like this is the most important question, is just any question. You just keep digging down. You just see why, right? If you don't know, keep asking why until you find the answer. Never check, like I guess never hold assumptions when it comes to like smart contracts or syntax, because we could actually look at compiler output, right? Like all these things are deterministic. Everything makes sense, right? So this is how we avoid hacks. This is how we actually onboard 1 billion users like we're talking about, is we tell the truth with our software and we don't fool ourselves. And we don't like just like to be like, I think it does this. We're gonna ship it. Because like that's how you lose people's money. That's how you hurt like I guess the reputation of like what we're trying to do here. So that's kind of my serious note. But then like we get to come here and we get to blow contracts apart, blow bytecode apart, and have fun and play with it, right? Because when you have playgrounds, when you have this element of play, stuff comes really quickly. Any thoughts or questions before we like kind of hop in?
I love this style. Thank you for the overview.
Sweet, yeah, a little different learning style, but it's how we do things. Okay, so today's topic, as you all know, is DN404. Does anyone know, besides you, what DN404 is? Are you familiar with it? Your comfortability with DN404, fist of 5. I'm seeing 3, I'm seeing zeros, I'm seeing no. I don't know what that is. I'm seeing a little bit of familiarity.
I read the description that said something to do with USD 20s and 721s. So fungible, non-fungible means like.
Yes, exactly. Does anyone want to give a stab who feels like level 2 or level 3 comfortable with what with what a 404 contract is? Kind of blew up. There was a little bit of hype, but it's actually really sick.
I thought it was called ERC 404, even if it's not an ERC, so I'm surprised about the name. But it's pretty much that works to like make a non-fungible fungible again, right? To be able to fractionalize NFTs.
Mhm.
7631. Is that your C7631?
No. So
No.
the joke is, there was this project, a little bit of lore. The project was ERC 404, which, like, we're at ERC 7000, right? So it's like standard not found, right? So they just kind of like invented this like horrible like hodgepodge of like an ERC 20 and an ERC 721 and like threw them together and called it ERC 404, and it like popped off and it was super gas inefficient. And then there was this, so they're called 404 tokens kind of in general. I think the name of 404 stuck, but then there was this like shadowy supercoder level group of developers that comes out of, I guess, like the Gaslight team. If you guys are familiar with the Gaslight team, they write very hyper optimized like assembly contracts for like kind of standard templates. They're all audited. It includes folks like Vectorize, like Pop Punk on Chain, Quit, Cygar, like a couple other like big Solidity names on Twitter. So just some like Chadley level developers got together and worked on this a revise of it called DN404, which is just a better gas optimized version that I think doesn't have some of the bugs that the initial ERC 404 had. So instead of talking to you about it, I'm going to show you it. Just to give you a quick overview. That's my face. That's weird.
What it stands for?
Divisible NFT.
I didn't know that. Nice.
That's my chest.
That was your one.
Is this sort of 420?
The name.
The what?
It's a DN420.
DN420? I don't know what that is.
I think it's an 1155 and ERC20 kind of.
We might be talking about the same thing.
Okay.
So, okay, to start. Oh, this is weird. Okay, cool. To start, I'm going to show you a DN404 project called Asterisk. So, this is the project called Asterisk. Notice we have two token addresses here. We have an ERC20 token address. And we have an ERC 721 token address. And notice I'm on OpenSea, right? So I'm looking at ERC 721s. I'm looking at NFTs. I can buy this. This is like a one of one, right? But what is up with the ERC 20 portion? If we go to maybe like OpenSea, Etherscan. We notice that here's the ERC 20 contract. So that's weird. So there's both, like, there's an OpenSea and there's also, I guess if we go to Uniswap, we could launch the app and then, like, you know, buy this token as well on Ethereum. So, like, maybe I want to buy 0.25. So it has a price, but I could also buy the art as well. So it's exactly what you think. It's exactly what we described. It's a co-joined pair of both like ERC 20s and ERC 721s. If you were to make a contract that both was fungible and non-fungible, how might you do it? Throw out some ideas.
I guess what properties do you want to connect them?
Yeah, so like I want something. I want to be able to buy the art, but I also want to buy a fraction of the art. Like I want to buy something like a fraction of something. If I don't have enough money to buy the whole thing, like if I don't have $1,000 right here, if I don't have $1,600, but I want to like, I guess, bet on the price of this going up, how could I buy $60?
So you want to be on fractional ownership so that you get the profit off of sales.
Right, exactly.
Okay.
Exactly. I ride the train going up as well as going down. So that was kind of like the design question, right? And why hasn't this happened before? It's kind of like there's some complex answers. So for example, like if I was to think about it, right? Be like, you know, the boss comes to you, he's like, hey, we need this contract. It's both like an NFT. It's both like an NFT and a token in the same contract, right? So you can hold like little bits, and then you can hold like whole chunks, and you can send, and users can like both like send and receive those tokens to and from each other. So they can trade them. They can also trade them on like a DEX. Oh man, here I go. I'm gonna try to draw a unicorn. There you go. They can trade it on Uniswap. They can trade it on Uniswap. They can hold the token. They can also see it as like a nice picture. They can see it as art. Hey, how's it going? Welcome in. Grab a seat, man, anywhere. So why think of some reasons, like the obvious thought would be, well, it should just be one contract, right?
Yeah, I feel like my gut would just be like a 1155 support.
Yeah. Right. Yeah. Like, why don't we have 1155 support like fractional ownership, right? It's a subtle reason why you can't do that. Because it makes sense in mind, right? In your head. The reason is indexers. I think that's a huge reason, is like indexing and off-chain indexing, is ERC20 tokens have transfer events. And that's how the entire infra of crypto is built up on like what balances are, how much people hold, et cetera, et cetera. NFTs also have the same transfer events, but they actually don't conform to one another. The event structure overlaps, but when you transfer an NFT, you say one. But when you transfer one token of ERC20, you transfer 1e to the 18 or 1e to the decimals, right? So you transfer like a massive amount. When you transfer an NFT, the number there in that slot is the token ID. So you transferred, 271 or 69420, right? Like whatever token ID it is, you transfer that. So there's like a ton of infrastructure built around how to list assets, which are NFTs, and how to list assets, which are ERC20s, how to price them, how to trade with them, et cetera, right? Like you can't plug a 721 contract into a Uniswap V2 pool or V3 pool, right? Like you can't have it trade like on a decentralized market. That's why OpenSea order books exist, right? So you can sell one for one. So you can't have like price curves, right? Like you can't do price prediction on some of these things, right? So it's like ERC20 infrastructure is really ERC20 infrastructure, and 721 infrastructure is 721 infrastructure. And you need those to exist at two separate addresses, because especially like, just as like a little aside, when you're building these things, has anyone ever dealt with event indexing?
I'm building one right now.
Cool. Yeah, so tell me why it would be confusing for indexers if you had a transfer event representing two different assets in the same place.
Yeah, because for exactly what you're highlighting is that a transfer on a 1155 is usually pointing to a token ID getting transferred, whereas a transfer on an ERC20 is going to be an amount.
Right.
With 10 to the 18 decimal points. It depends on the token, depends on the decimal places. USDC will have 8 decimal places. ETH will have 18, and so on and so forth. But the confusing part is these events are also named the same on the contract.
Mhm.
So when you're looking for indexing an event, when you're looking for just transfer, an 1155 contract is going to have a dot approval, a dot transfer, as well as an ERC20. But the point that you're highlighting is exactly the reason why it could be problematic is that the 1155s are transferring one single amount of token ID, and the ERC20s.
But I think 1155 still covers this. It's got the flexible event. You can do the flexible ID system where you've got the semi-fungibles, non-fungibles, and fungibles in the same contract.
I don't believe that's true.
1155 you definitely can't. 721 no.
Well-
1155 you can do all three in the same contract.
So there's, if I remember correctly, there's maybe an extra spot for data, additional data as bytes in the transfer event of an 1155, but I believe that the third topic of an event in 1155 is amount. Is that what you're saying, right? So it's like, it's from to amount.
It's like, but yeah, it's like here's part, like, yeah, it would mess up indexes. You use part of the ID space to specify what the token is.
Right. That's true. Right. And so like, what was your name, man?
My name is Drew.
Drew. Cool. So what?
Deco in the chats.
Nice. So what Drew is saying, haha, we just doxed Drew.
That's right.
What Drew is saying is that kind of like TLDR. I don't want to use one of our side quests on events because they're super boring, but they're really important. Sorry, I didn't mean to diss your project, but this is a Solidity meetup.
We have to index, building an indexer around 1155 contract.
Oh yeah, there you go.
We
But
also have to index ERC20 tokens for payout tokens. Have to index WBTC, but we also have our own custom 1155 implementation that we're emitting transfer events to, so we're transferring shares through that. So
right.
it's actually like very pertinent.
Oh, totally, absolutely. And if you build up graph databases, you know that like indexes are the canonical history of what happens on chain. Without events, on chain data is impossible. Like you have to build like the infrastructure around it. Like events are super important, and you can build beautiful state systems just off of compiling and compressing events to represent current state. And that's what graph databases do. And they're really elegant systems. Events are how SQL works under the hood. So it's like a sequence of update events that you can blow them apart at any point in time, but if you collapse them, they represent the current state. And so it is a really beautiful system to work with and play with. But as Drew was saying, the transfer event, these transfer events, they have 4 topics, which make them very easy to index and search against. And so the topic 0 is going to be the name of the event that's hashed, and so they have the same event name. And so like there'd be no way to tell the difference. What's the transfer of an ERC20? What's the difference between the transfer and ERC721?
And is that based off of the event schema? That there's different arguments for each?
It is the Kachak hash of the event name, and so it's you stringify the event name. So if the event is EV, it's EV, an open bracket, and then all the types without spaces. So address,
Sure.
comma, uint 256 address, and then tuples or structs are further escaped all the way down, and then end quote. It's the Kachak 256 hash of that, and that's your event topic. That's topic 0 for any event. So you have 3 separate slots now, which you can mark as indexed in your Solidity code.
Right. And there's and also on that note, to addendum to that, you can go as far as maybe 12 or 13 parameters before a stack too deep error happens, because it can only support like so much in memory for the event being emitted. But yes, 4 indexed keys, and one of them is taken up by the Kachak hash of the function the event signature.
And the index keys just make it very easy to search. Okay, so I don't want to lose you guys. Let's move on. But the reason why there are multiple reasons why you don't want to have these things in the same contract and people have tried it a ton of times, and it just doesn't work, right? So it's like you can't have an 1155, a 721. So I'll use this little hexagon to represent 721s, and this to represent an ERC20. You can't have them. You can't have them be at the same address, because one big important part about events too is there's an address. So you want to know their trusted space at which addresses are emitted, and that address field is super important when you're indexing things off chain. Let me just look in the chat here, see if there's any. Nuke, could you keep an eye on the chat for me? Sweet. Okay. All right. So how could we? So here is how ERC. Here's how these 404 tokens work. I'm going to give you guys a high-level overview, and then we can dive into life cycle, and then we can do technical dives. So here's our ERC 721, and here is our ERC 20. If I look at my notes real quick, I believe, yeah. And so we'll see that the ERC, this contract is called the DN404 in the code, and this one is called 404 mirror. And that's a good hint. So we have users here, right? Users here, and users here. Okay, I'm gonna make this kind of interactive. So if I went to the 721 and bought one token, or got one token, I don't buy it from the contract, but I get one token, maybe it's token ID 21. Guess, what do you think happens? Oh, I broke this pen. Any guesses on what might happen? Because we know that like when you get one token in an ERC 721, the balance of basically decrements from the sender and increments to the receiver, right? So they have one less, you have one more, and the owner of 21 is now no longer their address, it's your address. And that's the NFT standard. Also, that transfer event is emitted from the contract.
What is the first part of that? So the second part definitely makes sense. You can do like owner of token ID, and that address value gets populated on the 721 contract. But you said there's like some kind of accounting balance for like how many of those token IDs that you hold?
Yeah, so NFTs actually also have a balance function as well. So you can call balance of on an NFT and say I own 4 CryptoPunks. CryptoPunks is a bad example because like that's not actually it's not 721. But say I have 4 apes or whatever, right? Or I got some based punks. I'll say 4 based punks, right? You call balance of my address 4. Right. So there is a slot that like I have storage on that says like Colin has 4, right? But then so there's I guess 2 really main functions on a 721. Just to recap, it's balance of user, and then this returns a number, and then there is owner of ID token 21, and you get back the address of a user. Just to recap. But back to the original, does that answer your question?
Yeah.
Cool, sweet. But back to back to this question here of like say user, and this is a bad mental model for tokens. Tokens don't actually send stuff to your wallet. It's just an internal storage that says who owns what. So I'm sorry for this. Disseminating poor mental models. For those of you who are especially a little more new to Solidity, this was like a big hurdle for me. It's like, wait, tokens aren't actually sent to users. It's just like storage marked somewhere on a contract. Yeah. But anyway, we're gonna use it because it makes sense in a graph. Say I get, this is me, I get token 21, I get one of them. Well, obviously because there's only one token 21. What do you think happens? Some ideas.
After the transfer is made?
Yeah, after, because in addition, remember, the idea of this is it's a co-joined pair. We went over this a little bit before you hopped in.
I'm not up to speed.
If I own 0.5 share, if I own one share of a token, that's not the whole thing, is someone allowed to go and buy the whole thing?
Say that again?
I own part of something. Can someone come along and buy the whole thing? Or is it like permanently fractionalized at that point?
We'll get there. That's like that's like 3 questions away.
Fractionalized,
Is that
21.
That's what I'm like, when you ask that question, I'm like, but how does it play with that? So that's where
Right, yeah, no, exactly. This is where things get fun.
I was wondering too, because the OpenSea thing.
Yeah, right.
It says by now, so.
Yeah, how is there an open sea, right? There's one thing. But yeah, like this is a 721, right? This is an art. This is a picture, right? There's a picture behind this, right? So I get token ID 21. What do you think happens between these two?
You get allocated some tokens or something?
That's right. How many do you think?
You tell me.
It's actually, yeah, it's 1.
One.
So you get one whole token, 1 e to the decimal, right? So what happens? I get token 21. The ERC 721, the mirror contract talks to the ERC 20 contract. It says, hey, Colin just got 1 token, and then it will mint me 1 token to represent. But like cause since tokens are represented with fixed point math, where we say, really on the blockchain, what's stored is 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's 1 e to the 18, right? There's no decimal points, so we just use a lot of zeros, but there's an imaginary decimal point, right? But when you hold 1 ether, you really hold this amount here. So that's the important part, right? Like it mints you 1 e to the 18 worth of these ERC 20s. So you hold both.
And remind me again what this is a solution for? What you're building for?
Fractionalized NFT liquidity. To give NFTs like liquidity.
Okay, yeah.
But to have like the liquidity be custodied. Right? It's not like I put this into a pool and the pool has some kind of value and like the value is speculative on whether or not it would sell at a market rate and it, like sort of speculated on floor price because that's the way you could do it, where it's like, you know, I take all of our pieces of art, put it together in a pool and then issue tokens based on that pool and say, hey, like, you know, given the floor price, these tokens are probably worth X, Y, or Z. No, 1 token here is instantly redeemable for 1 piece of artwork. And 1 piece of artwork is like they're a co-joined pair. The balances are represented in both places.
Mm-hmm. Right.
So there's
just wanted to ask.
right, exactly, because like maybe I like this thing, and I like the floor price that I'm seeing here on asterisk. Right. I'm liking the floor price at 0.4 ETH. And I think it'll go to 0.8 ETH, but I don't have that much money. I just want to throw $80 in because I'm sitting there at lunch poking around on my phone. I'm not trying to spend $1,600.
Right, so you're speculating on the price of an NFT going up, so you want to buy it while it's cheaper.
Yeah.
But remind me of the like fractionalized part of it, or
Yeah, well, so like the NFT problem is like, I'm sure we all want to buy, like especially back a couple years ago, we all wanted to buy a part of like apes or CryptoPunks, but like unless you have that initial liquidity to put up, you can't be really a part of that. Or also if you get like, I don't know, if you just have a crappy one and no one likes the way it looks, then whatever, right? Like,
sure.
so
So you
it's
don't
weird.
have like the 212 ETH to buy the Bored Ape.
Exactly.
Peak of NFT season.
Right, but like you want to have the same upside that the guy who bought the ape at 4 ETH and then rode it to 100 ETH, you want that same upside, but you don't have the 4 ETH, right?
So it's a mechanism to bet on the price of NFTs, so like speculate on them without maybe possibly owning.
It builds more liquid markets around NFTs themselves, right?
Yep.
Like they
Yep.
can trade as individual assets today, right? And that like limits the like lendability of that. Like they're non-fungible. It turns them into something that is more fungible and more liquid. So I think that's where it goes at, is like the financialization of these assets opens up a lot more when you've got this fractionalized ownership, and you can have markets where you're trading across many users instead of just a binary of one user and one seller, one buyer. It's like now you've got markets that can form around them.
Right.
Yeah.
So you mentioned up front that the initial versions had issues with cost. But just the fact of keeping separate balances on separate contracts here already seems like it's going to be fairly high on the cost.
Yeah. Exactly. So you want to minimize the cost as much as possible and make sure that you have like a very efficient way of doing this, because it is costly. It is costly. So, Fist of 5, how do we feel about this first flow, understanding wise?
Yeah, so to recap, you mint a token on you're actually interacting with the 721 contract, or a contract that implements 721 that also is implementing an ERC20.
Right. Exactly.
And you interact with this contract, it calls, safe mint on the 721, it does the transfer, it updates the owner of, it updates the balance for the 721.
Yep, in the NFT, yep.
Yep, and then subsequently in that same function, it will reach out to the ERC20 and
Yep.
Mint one new token,
To you,
to the message sender.
to the buyer.
To the buyer.
Yep, that's right. Absolutely.
Okay.
So is the right way to kind of think about this the money Legos thing, right? But we're composing two independent tokens contracts, right? Open Zeppelin, I think, is what we're using for these. Is that right? No, something totally different. So it's unique. So it really isn't two independent things that are coupled with a higher level contract. It's now like a combined thing.
Mm-hmm.
Okay,
Mm-hmm.
got it.
And is it starting with just a 721 and then layering on this, like mirroring to be able to fractionalize it?
Oh yeah.
Or is it out the gate that it's
Like how would you
built in
define
this
your,
way?
like you would define your contract, like my custom contract, is it extends ERC 721 imported from Open Zeppelin?
We can get into that.
Right.
We'll get into
Right,
what
like-
the implementation
Yeah,
details
so I
look
take
like.
my CryptoKitty and then like fractionalize it
No,
retroactively.
you have
or
to
post-hoc,
build.
right?
You have to. That's a great question. You have to build this out of the gate like this.
Are
This
there
is-
mechanisms for fractionalizing? I'm sure there are.
No.
Probably with like you'd probably have to like escrow it and then distribute it as an ERC20 or
Yes.
something else, right? Where it's custodied somewhere and
That's correct.
redemption would be from like maybe 100% ownership or some sort of other
Yeah,
reclaim thing.
that's correct, and it's really goofy because the like
Very
you'll just never get all the liquidity back, and it's also like pure speculation because there's no like 1-for-1 redeemability.
Twin flames or something like that. There was like a big NFT thing a few years ago that I think was doing something like that.
Interesting. Well, so just to like give maybe like a user flow, right? Because like we only understand these things insofar as we use them. If I hit buy now, right? Get on my MetaMask. We all remember how terrible software MetaMask is.
Is it Ravi the
Yeah.
what's these days?
Arabi is indeed the wallet of choice. I don't want to check out with MoonPay. I just want to click this one. Oh, okay. All right. So, anyway, I guess MetaMask is just going to flip out on me. But basically, like, I would go to buy now, and I would go through an actual checkout flow of buying this token. Once I bought this token, I would hold this piece of art. I would own this asset. I would hold this 721. So if you went to this smart contract, the NFT contract here, and if you queried, for example, like if you went to the read and you said balance of, reuse 1882.eth, right? And this is obviously not an ENS. So it would say 1 because I bought 1. I have 1 token. I can see the artwork. That's how NFTs work. On the left-hand side, on the ERC20, when I go to the contract and I read balance of, and I type in, maybe we can find someone who has some balance here. Let's find cashguy.eth. Let's grab his. Yeah, I mean, how could Cashguy not have balance? So it would give me 1E the 18. Come on. It would return this number to me, right? It would return 10 to the 18th. So I get one ERC20 and one 721. How are we all feeling about that now?
Makes sense to me. Because
Cool.
I've worked with them.
Dope.
Who is this new board?
Who is this new for?
Yeah.
The 404 stuff?
Yeah. Well, yeah. I walked in late, so.
Oh yeah.
What is the 404?
Now it comes now. Right,
What do you mean? What is the 404 what?
What is is this a 404 token? Or what is this?
Oh.
it's a. Go for it.
So ERC 404 is,
Oh, it's an ERC.
it's not an ERC. It's a project called ERC 404.
Okay.
It's a token, it's a unstandardized token standard. That's new. It kind of blew up on Twitter
Interesting.
like 2-3 months ago. And it's a co-joined pair of 2 tokens.
No, I had no idea.
Of an ERC 721 and an ERC 20.
And is it in an EIP? Or is it an ERC? It's a candidate?
No.
So
Yeah, it's not an
it's
EIP.
not, it's just kind of like an underground.
It's just like an underground thing. It was called ERC 404 because the joke is standard not found. That's it. Yep. And then a group of developers from the Gaslight team went and made like a gas optimized version of it, which we're gonna dive into because the Solidity is like gnarly.
That's sick.
It's sick. So this is what we're talking about. It's a co-joined pair, right? So like normally in ERC 20 and ERC 721, you just get a balance, like it goes back and forth. ERC 20, you just get a balance, like et cetera, right? So we talked about sort of the problem space, and now we're in how this works from like a user flow, how we'd use it, right? So like flow number 1 is like I get 1 token, and it just like it gives me that 1 token. I get token ID 21. It has a piece of art, and I also get 10 to the 18. I get one token of the ERC 20, and so I could do whatever I wanted with the ERC 20, or I could do I shouldn't have done that. I should have just kept that, or I could do whatever I want with the 4.
Yeah, it seems like if you were to transfer out that 1 from the ERC20, that balance of 1, let's say to another address,
Yeah.
that might break the relationship between the 721 and the ERC20
Exactly.
itself. Like it could cause, you can see that definitely causing accounting issues. So there should definitely probably be like some guardrails around like who that can be transferred to. And yeah, some overrides probably to the transfer.
But they're not. They're spec compliant. So I can transfer my ERC 20 however I want, which is sick. But it has to be represented on the other side.
And another thing that stuck out to me is that it's a 1-to-1 mapping. It's like minting 1 token.
Mm-hmm.
for every one token ID.
Mm-hmm.
But like fractionalization could be like you and I buy that asterisk NFT and we both put it in half, and so we both get like 5 E17
Mm-hmm.
instead, right? Like so that also sticks out to me that there's like this 1-to-1
Yeah.
relationship between the ERC20 token and the token ID.
You're on it, dude. Yeah, no, you are. So one is I get, basically, if we were to say in English, I get, NFT 21. I get 1 token. Okay. In like, I'm gonna throw another flow at you, and then I want you guys to start coming up with like some thoughts or like some thought experiments. Like, what doesn't make sense? How can we break it? What will happen? Right? Like, hit me. Like, but let's just go one more real quick. Number 2. Number 2, I come to the ERC20. I buy, because we can buy ERC20s on Uniswap. I buy 2, or I'm just gonna say 1. I buy 1 ERC20 on Uniswap. What happens?
Yeah.
Oh wait, I'm not.
Is that a permissionless action, or is the person?
Nope, completely permissionless. It's open DeFi, right?
So anyone could buy shares of the 404 that I own.
Yep. So here we're gonna go back to Uniswap. I'm gonna plug in asterisk, right? This is flow number 2. I type in 1. I buy 1 asterisk. The current price is $1,300, because that's what the decentralized market maker says it is in the curve, right? Like, it's just a pool, right? I buy from Uniswap. What happens?
I would say that you would want to have some kind of minting happening on the 721, possibly. Or there needs to be some relationship between like what token ID those mints are happening for. So like, and why is that important is because if you buy the NFT and you own 1 share of that, I can also come in and say, I would like to own 1 share of that asterisk token as well. But if the sole purpose and utility of the ERC20 token is to relate to a token ID on a 721, then there should be some kind of mechanism for making that relationship. That's from this user flow, so like interacting with the ERC20 directly. I think just as with the first user flow, where there needs to be like an underlying mint on this ERC20, there should be the inverse of that as well.
They should talk to each other.
Right.
It should go both ways.
I
Exactly.
think this view clears something up for me. You're not buying a fractional piece of a NFT, you're buying a fractional piece of the collection as a whole.
No.
No.
Wait.
How is this price derived?
You're buying from the pool, right? So
From the pool. You're buying from the pool. You're buying a token. So ERC20.
And is the pool representative of one of this collection's NFTs, or the collection as a whole?
that's all, right?
No.
It's not.
You buy neither.
It's decided by the market. Great question. It's just decided by the market. But
Interesting.
guess what? Like, we all own it. Okay, say there are 10 NFTs. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What's up, Red? Okay, there are now 11 people in this room, right? There are tokens trading here in this pool. There are 11 people in this room. The total supply of tokens is 15. Right? There are 11 out of a total 15. If someone goes and buys 1 token from the ERC from the Uniswap pool, like, I want to keep my art, what happens?
I mean, you're buying from a pool, right? So
Yeah, you're
people-
buying an ERC20 token from a pool.
So people stake it, right? So they put some of the fraction.
There's
of the
liquidity
NFT.
in there.
Yeah.
They just put an ERC20 in there. Remember, unhook your mind from like it also being an NFT.
Yeah.
They're just like they just kind of relate to each other. But yeah, it's like there is.
So you just have 2.0 ERC20 tokens, but they're not directly mapped to specific NFTs.
Exactly. There's not mapped. But so basically, what happens is like say that there are 4 NFTs left, right? And by the way, the total supply of these have to equal, right? Because like that's a clear invariant, right? So the total supply of the ERC20 is 10,000, right? And the total supply of the NFT is also 10,000.
So
It
that's
can
an
never be
invariant.
more or less than one another. They have to have the same total supply. That's like a huge invariant issue.
Definitely run this through fuzz testing.
Yeah, absolutely, right? And so what happens is
Would it devalue the 11 if there's 4 extra that are floating around in the pool that are just extras? Would that devalue those 4 extras price wise and make the 11 that are tied to an NFT more valuable?
so look at what we see here.
Not sure.
Look at what we see here. So the market has currently decided that because like we agree that markets are efficient. So they'll determine what the price should be. The price of the ERC20 token, look, I can buy one ERC20 token for $1,300. The floor price currently on Asterisk is 0.34 ETH, which is this is right at floor, which is $1,600.
Okay.
So your thought is like is
Floor
But
price
there's less value in the ERC20 because it's not tied to a piece of art, right? So it's like I don't own anything, right? I'm not like the owner of Coinbase because I have a Coinbase stock, right?
exactly. You can't make
sharing,
decisions.
sharing the benefit of its upside or whatever, right?
Right.
But I have no decision making. Whereas if I own the actual underlying like ERC 720 or whatever it is, I have the asset. I could commercialize it. I could do whatever I want with it.
It's
So there's
some-
more value.
it's
inherently
somewhat
in
more of a
that
commodity.
for some people.
Right, exactly. And like maybe you get a really cool one,
Yeah.
right? And it's cooler to own that.
And then rarity comes into like how it's
Exactly.
valued, right? Or like the aesthetics of it, like are better for one. than
No,
the
it's
other.
clicking. You're seeing what this is like a market tool, right?
But and so these seem and sound like 2 completely different markets with different externalities in play.
Yeah, but like
They're tied to each
They're-
other.
they're tied to
Like
each
the
other.
Same
So-
underlying fundamental system, right? Of like the art or whatever. It's just like I think the capacity in which you have ownership over that
Is
is different, right?
pricing.
Yeah.
For,
It
like,
creates pricing differential.
It creates a
Yeah.
pricing
Yeah.
difference, right? So we know that for sure that owning the token ID is a lot more valuable, and the market external factors value that as 0.43 ETH on OpenSea.
Yeah.
But
Higher risk also though, right? Because it's less liquid. I have to sell that entire thing if I want to get value for it. Versus an ERC20, I could sell a portion of it,
Yeah.
right? Or just sell it back at a discounted rate, right? So
Right.
it's easier for me to discard this and get out of this position. So it's like different risk profiles and different benefits I think,
Absolutely.
for each of these
Yeah.
assets.
and I want to delay philosophizing about this so that because it is
Sorry,
super
yeah.
interesting and I totally agree. I think that like everything should be a 404 because it's brilliant. It represents like an asset, like it's like a perfect fractionalization of a commodity on chain. Like it's a really fascinating mechanic. Like I think if you launch anything, you should have it be a 404 because NFTs are like hard to trade and they're illiquid, and ERC20s are easy, but like you could do better.
Well, it
right?
depends on the purpose, right?
Well, yeah,
What do you
sure.
mean for what kind of asset?
We'll talk
right?
later.
Yeah.
But so what you were saying, they're not linked 1-to-1, but they are like there's a reasonable amount of price differential that the market will allow for because they are kind of redeemable 1-for-1.
Yeah,
So
that's an interesting dynamic.
it is an interesting dynamic, right? So I buy one ERC20 from Uniswap, and guess what? There's 4 ERC20 tokens that are left, and so it's just like it's like a dice roll. So I buy one ERC20 off Uniswap, then my address becomes the holder of that's ETH. my address becomes the holder of one token, right? So I now have one token. The ERC20 talks to the 721. There's a random unminted pool, and then it mints me one random new NFT with any ID ranging from 12, 13, 14,
Up to
15.
2,000.
Maybe this is not right. Maybe it just mints me the next one. I'll have to check my assumptions. I don't know. We'll have to look at the code, right? But like that's the idea.
So wait,
I
it mints
can't-
the
I
NFT
can't
for
yoink-
So you get both the ERC20 and the NFT.
Uh-huh.
Oh, okay.
Yep.
Does it work the inverse way? Like if you get the NFT, you get the ERC20?
Exactly. That was our first flow, right? So if I get one, perfect. Exactly. You're in it, right? So if I get one NFT, I'm also minted one ERC20 to represent that NFT as well. So I have liquidity that I can play with, right?
Wait, can I then sell half of my ERC20 and maintain the entirety of the NFT?
Boom, great. This is what I wanted to see happen. Okay, user flow number 3. So I hold one, right? Or I hold one. I sell 0.5. What happens?
Do you own half the NFT? Can somebody else
Well,
buy
you can't
it?
fractionalize. That's the problem you're
Still
solving.
on
You can't
the
fractionalize the NFT.
Right, exactly. Exactly. Great question though. Great question.
Yeah,
Yes.
the NFT,
Yep.
you cannot transfer it. Imagine.
The NFT goes.
You still own the NFT. You still own
Nope.
the token ID. If you still look up owner
No.
of.
Nope.
Wait. Okay. Wait.
Yeah.
Yeah, no, you don't.
You sell. All right. This is the 3 is you're selling the ERC.
Yeah, wait,
I
are we
hold.
selling
I
and
hold
holding your-
one ERC20.
Yeah.
One whole ERC20, and I sell 0.5 ERC20.
Yeah.
What happens? The NFT.
You still own it, but cannot sell it. No.
Nope.
Does it go back to the pool?
Yeah. Does it?
It goes not the Uniswap pool,
Uh-huh.
but it goes into this thing called the burned pool, and it's burned.
Yeah.
It's
yeah,
burned.
It's burned.
So is it sent to 0? It's sent to the 0 address.
It does it. I don't know how they handle the transfer events, but we can look
Yeah.
at
You
that.
can burn any token.
What if
It's
I-
to the same.
Is
Red.
burned the right terminology, considering if I go buy 0.5 ERC20 from someone else, and now I have one ERC20, I can go like regenerate, but it's not a new one. it's
Aha!
already burned, no?
User flow number 4. See, our minds are firing on all cylinders. Okay, so I have one. I sell 0.5. I then buy another 0.5. What happens?
Okay. All right. Okay.
Let's finish this one, but we're gonna dog ear this. Okay, I hold one ERC20. I sell 0.5 NFT. What happens? Where are we at with that? Someone say, what happens?
NFT gets burned.
The NFT.
No one owns the NFT.
No one owns. I no longer own the NFT. No one owns the NFT.
So
Does it-
is my half of an ERC20 representative of some fraction of now 14 NFTs?
No.
The value
Only,
derived from that? If
only,
there's one less NFT in the whole collection?
only in theoretics, and only for what the market determines is reasonable. Because there's always a natural. There's both like there's a human value arbitrage and then also a market arbitrage of like, this is cool, I'll keep it, and also it's efficient for me to sell.
Yeah.
And looks like with Asterisk, that's about $250. So that's not a perfect market because people like cool stuff,
Mm-hmm.
but it is tight
Mm-hmm.
for like the decentralized like open dark forest of Ethereum. That price is holding in 2 open markets as 2 separate assets within $250 of each other.
And would this have an effect of narrowing the price range of NFTs in a given collection?
That's an interesting.
Like, you know,
that's
like
an
I-
interesting
I-
psychology, right? Because
Yeah.
then rarity isn't as much of a factor. Is that what you're
Right,
saying?
Yeah.
Yeah, sure. I mean, I would have to look at the analytics,
How
right?
it plays
Like
out,
it's
yeah,
a
in
total
practice,
experiment,
right,
right?
yeah.
Like that's the fun part. So I hold one ERC20. I sell what happens to my NFT? No more NFT. I don't have an NFT. The NFT goes back into the pool. The total supply is decremented by 1
It's
on the
just-
NFT.
Okay, so it can't be minted again. It doesn't do any internal account keeping on which possible token IDs open up that were previously minted.
It can be minted again. It is put
It
back
gets burned.
the burned pool.
Burn pool.
The burn pool, yeah.
Oh, it can be a phoenix, rise from his.
Yes,
Actually,
yes, yeah, but you don't know what you're
Yeah.
gonna get until you hop in, right? So
Typically, like token IDs are just, it has to, I'm assuming that it probably has to do some kind of internal accounting for token IDs rather than just a simple counter. It used to be counter, or it could be its own implementation, just plus
super
plus.
complex.
Right. So I'm assuming there's accounting to keep track of, oh, this user flow 3, we gotta burn a token. It
This
goes
is
to this
good.
burn pool.
Wait,
This is good. Everyone is, yes, we're all
can
here.
we then have more than 15 ERC20s for the whole collection? Because if I
Nope.
sell half of my token, my ERC20, and it burns one, and then
Mhm.
someone buys one,
Mm-hmm.
isn't there now 1.5 that are tied to the same one? I mean, it's been decoupled, but then
Total supply are the same. Total supply are the same. So as long as there's fractional holders, like you could say, so here, I'm just gonna look at
No,
this
I sell
intuition.
that half
Look, wait,
anyways,
look at this.
but
Look at
it's
this.
still there, yeah.
Boom.
Mhm.
Items. This is the OpenSea. This is the listing for the NFT. Look at how many items there are. Someone say it.
7,490.
Yep, absolutely. Let's go to the token contract, which is here. Etherscan address. The token.
It's not really burned; it still exists.
The token contract. If we go here, if we look at total supply, that number is divided by 10 to the 18. 10,000.
Mm.
So there's always 10,000, but look at how many whole assets there are. 7,000. What is that? What can we deduce from this statement? If there are 7,000 whole assets,
Oh, is that the price difference then?
nope.
No, that means there's
Close.
2,500 that are in the burn pool.
Yes, right. There are 2,507 that are unminted.
Yeah,
Right.
There are 2,507 that have not been minted yet, or maybe have been
There's
minted.
possibilities, yeah.
Yeah, they have been minted, but now they're back in the pool. Or also too, you could say that at least, that there are 25,000 fractions out in the market.
Yeah, those are all, it's all an indication of number of these scenarios. It could just be that it just hasn't capped out, it hasn't minted out yet,
Mhm.
and that's just still incrementing. Or they indeed
We'll
sold.
be back in like 30. How long is this going?
We'll probably be here in 30, but
Okay.
yeah, we'll see. We'll see how far.
So how do you remint, like say you have one ERC20, how do you remint an NFT and is it randomized or? do you
Red's
choose-
case, number 4.
Or do you choose which one you remit?
I'm gonna call this the re-roll case.
I feel like there's like a whole design space here where each token could pick their own thing. Like, is it more interesting to have them go back into the pool, or is it more interesting to get an entirely new one and the pool composition changes over time?
Yeah, right. No, it's super.
You need a mechanism to generate new ones on the fly instead of like pre-generating set amount.
Uh-huh.
But if someone burns a very rare token for some ERC20s, you now get a frenzy of activity, trading fees, whatever comes with it for people trying to cash in their tokens. They don't get a rare, they trade again.
People have liquidity, they buy,
Do a
sell.
lot there. Yeah.
There's a ton that you can do, right? And so you can have this cool art, but then also you can do DeFi and not ever care about the art. Number 5, this is really interesting.
That's powerful.
Number 4 is really interesting. It's the re-roll case. So I have one NFT, I sell 0.5, and then I buy 0.5. So I have one NFT, my balance goes to 0.5, so I no longer have an NFT. I have 0.5 ETH. So my NFT of ID, 21 is no longer belongs to me. It goes thrown into the burn pool, right? And then 0.5, I acquire another 0.5. Guess what? I now have one whole token. So then I get minted a new NFT. I get re-rolled. I get NFT 34.
Yep.
I like it more. I keep it. I want to actually trade. I want to do DeFi stuff anyway with this. So maybe I buy another 0.5 just to hold it, and then price goes up, I sell 0.25, you know, maybe price goes up again, I buy 0.75, so now I have, you know, like 1.75 or whatever. Maybe I buy 0.5 again, so now I have 1.75. I still have one token, that's it. But I'm buying and selling ETH. I'm buying and selling the ERC20 over here, right? And then I can sell all the way down to 1 ETH and still hold my token. But the moment I go to 0.999, I lose my NFT. I lose 34.
Yeah, I was going to ask about that. There must be some kind of requirement on when it mints a new token, and it's got to be, in this case, 1 E of 18 per token ID minted. And so that might be a configurable value that you could say, well, actually, like they only need half of this ERC20 token to own 721.
Yeah.
Right?
Yep.
That was my first thought.
But that would mess with the invariant of the total supply differential, and you just got to make sure you really know what you're doing.
When I buy up from 1 to 2, I now have 2 NFTs.
Yep. Exactly.
Like maybe this is expanded to add configurable values in the constructor, and this is one of those variables that can be configured.
Yeah.
And then, but the invariant has to directly reflect that.
Yeah. Or else you break things and things get messy. Any questions about the mechanics? Anything coming up?
It's really cool.
Yeah, I like how everyone's mind is like buzzing of like, oh, you could do this and this and this, right? Because you can, right? Like you like this artwork, everyone likes this artwork. Well, guess what? You can now create a lending market that like works with Aave and every other lending market that's battle tested with billions of dollars in TBL, right? Because like you can just handle this stuff, right? Like by default, you can create Uniswap pools, you can do anything that ERC20s can do.
Is anybody building on top of this right now? Is Asterix a project that's
There's a
implementing
few
this?
projects, but there are this is the so Asterix is the project from the crew that turned the ERC 404 to the DN404. So the ERC was done by a guy on ChatGPT, and he launched it, and it horribly crashed. A couple of devs reached out to him and said, "Hey, we can fix it," but he had no interest. So then this crew got together and they put together the DN404, and this is one of the main projects on 404 right now.
It's very cool.
Yeah.
So clearly, OpenSea integrated with that. It's like, I know there's like something like if you do your 1155 in certain ways, like OpenSea doesn't know how to parse it. Did they like specifically work with the OpenSea with this team? Do you have to be like very tight to their spec?
Well, this
Because
this is a regular 721.
It's 7. That's the beauty of it.
It's the separate contracts.
It's the separate contracts, so it's automatically compliant with everything out there. You had to reach out to no one. No one has to fix anything. Like it just works.
I wonder what their metadata for a particular token looks like, and if there's any interesting things that they have put in their metadata, interesting keys that might represent like how many tokens are minted per ID, for example.
Yeah, I
Or if
wonder.
it's just very basic like image, and I would be interested in seeing that.
Yeah.
Because I've actually done like baked in royalties on transfers for 721s before, and part of that for figuring that out was storing like a key of like beneficiaries in the metadata itself, like an array of like contributors or beneficiaries, and then it would like cycle through those results stored in the metadata to determine who gets paid what.
Yeah.
There's like a lot you can do in metadata. It's like not the most foolproof, like it's not the most like robust fixed point math Solidity type security, but it can be used as a tool.
Good
Oh shoot. Am I? Yep. My bad. We were looking at this here. Okay.
it's just
So
trends,
let's take a little breather here, It's been a hot minute. Are we feeling comfortable with like the mechanics of this?
Yeah, I still want to know how it means. Like, is that randomized or not?
Yeah.
I'm looking at the code and these are songs. There is no comments in the code. So.
It's very
Yeah,
strict.
it's super dense. Yeah, how do we, any other thoughts, questions?
Is there a website for it?
Yeah, it's,
For the DN.
no, for asterisk.
No.
The website for is asterisklabs.io. It's pretty cool.
Oh,
Pretty cool.
Yeah, they got some cool stuff going on here.
some WebGL stuff.
Yeah, they're staking. They're trying to pump their bags as much as possible. I'm just gonna say it.
Do they have points? Dang.
They have points? What do you mean? Do they have points?
It's all the rage.
I said, points, brother.
Points.
Yeah, I don't think they have points. But yeah, see, look, you can both buy Uniswap. Anyway, so how do we feel about hopping into some code?
Yeah.
Good? Good. Okay. Also, hard stop at 3. We've been going for it. Like, I think this should be no longer than like a 2-hour meetup. Let's do a hard stop at 3 and call it there. Okay, so maybe we can we turn off the lights in here to make things a little more friendly on the code. You guys could also go to the stream. Oh, the stream will be super behind. Never mind. That won't be good. Let's see, are there any questions in the stream? Any thoughts? Nope.
Did you share a link to the source code?
Did not.
We should do that.
GitHub or
To the source.
GitHub.com/vectorized/DN404. Let's try it. Yep. Feels so good to type in a raw URL and it just like works. Here we go. So yeah, vectorized DN404. If you guys are interested. We're gonna go through the research repo that Marco put together. That I have that myself on my local, but this will show you the 404. Oh wait, there's a 420. Sam, what Sam was saying. I don't even know what 420 is. That sounds, yeah, right.
For 1150.
I wonder how old it is.
That sounds super gnarly. That looks new.
Yep.
Yeah, there it is, the 1155, combine it all. Single beam.
I don't even know how to I don't even have a mental model for that. That sounds so gnarly.
Right, it's because you have to do free form with the IDs in 1155. Like there's probably one ID that is the NFT side of it, and you do like that at like a high bit set, and then that's like the fractional piece of it.
Oh, yeah, maybe. I don't know. Let's see. Okay, so here's the 404 and the 404 mirror. Remember the 404 is the ERC20, and remember the mirror is the NFT. Okay, so is there any place where people want to start in the code? I'm gonna open up the 404 and I'm gonna open up the 404 and I'm gonna open up the 404 mirror as well. Oh, there's like actually implementation notes here. This is super nice. This is new.
They worked on it.
Yeah, they give some docs. Where do we want to start? Any thoughts, or shall we just start cruising?
Mint.
Mint. Okay, let's see. Mint. Is there a mint function? Yep, there is. Function mint. Mints amounts of tokens to 2, increasing the total supply. Also, is that a good height for everyone? Up, thumbs down, more or less? Good, okay. So, we'll mint NFTs to 2 if the recipient's new balance supports additional NFTs and the 2 addresses skip NFT flag is set to false. So, some interesting thoughts here. What's a skip NFT flag? What does this mean where it says supports additional NFTs? Those are some questions. Note, may mint more NFTs than amount divided by unit. The number of NFTs minted is what is needed to make 2's NFTs balance whole.
My guess for the skip would be the situation where you buy the ERC20, you go over the threshold, but there's nothing in the pool you want. So you'd say like, hold off on actually minting, would be my guess.
Yeah, that's a good thought. That's a good thought. We can look into that. All right, mint. So first off, if it's checking if the to address is equal to the 0 address and will revert, then it loads up a storage reference to the DN404 storage. This is where you stop me on syntax. This is where we get interested. Like, we can do rabbit holes. We have our side quests available to us a little bit. So actually, I'm gonna say let's go top to. Okay. Yeah, that's a chunky call. Let's go top to bottom and then see if we have any questions. Okay. So we load the address of the receiver of the 2 amount. So there's storage for the 2 address and there's storage for the 404. I'm gonna swap back to here. I'm gonna go to mint because I'll be able to, this should be the same. I guess this code is old. I guess they updated it. Let me clone this down just real quick. So I can like open up stuff not in GitHub. Okay.
The get skip NFT function is interesting. The dev doc, so it returns true if so it skips it if minting and transferring ERC20s to owner will skip minting NFTs. So this is a transfer to an owner.
If you send a whole, so I don't know if they updated the code, but the whole time, if you send a full token at once, to save gas, it would skip the burn and remint. It would transfer the NFT to the address as well.
What? That doesn't follow.
When you send a whole ERC20, one whole token, there was the optionality for skipping the burn of the NFT part of the mirroring NFT.
Okay.
So if I send you a whole token, the NFT would get sent with it without getting burned and reminted into your wallet for gas savings.
Interesting. So there's the get skip NFT. Okay. So it returns a Boolean, right? So what they do is they pack, they have these flags within the address data of the owner, and they do all this crazy code here. So check this out. Here, there is address data. So I'm going to open this up to the right. We can say there is, we'll find the address data in storage. Where's the struct for address data? Oh, struct address data. So there are flags for initialized and skip NFT. So uint8 is 8 bits. So you have 1, 2, 3, 4, 5, 6, 7, 8. That means that technically you have 8 slots to include flags here, right? Solidity doesn't allow for, so you could have 8 different flags. Like maybe this first spot is like, is popular, 0. This one is like, has a red cape, 1, right? You know, like they're just true or false values, right? Because they're binary. So you can pack up to, this is like just kind of some Chad level gas optimization where you can pack up to 8, 0, or 1 values into uint8. The reason why they don't use bool is because bool is also a uint8 by default. It's not a single bit. So they use only uint. So what you can do is you can use you can.
If it's just 8 zeros and 8 ones, or 1 and 7 zeros, like for bool.
Oh, for bool.
That's a side
Yeah. It would be 7 zeros and a 1. Yep.
You could technically still have the bool type there, and you're still just doing the bit fiddling at the symbol. They're both going to take out. Like, I think that would still compile for the most part.
Well, it would compile, but so what you would have to do is you would have to say skip NFT flag is bool, and then I guess there's, what are these, initialized is another flag, and at that point you have 88 plus 8 plus 8 plus.
Yeah, not doing it that way, but like the type here, I think is like, they're both types that are using up 8 bits, and you could still do the same bit fiddling against uint8 versus a bool. Like you're kind of breaking the meaning of what that is, but.
I get what you mean, but yeah, you break the semantic, the what is it?
Why are they
Idiomatic meaning.
Is my question for those reasons. It's like,
Well, because you
confusing the semantics of it.
Well, so no, because it's abstracted. In the storage, this is called flags. But when I want to understand if an NFT is skipped, I call this function, it returns bool.
Well, that makes sense.
Yeah.
That makes sense.
So what they do is they use something that's like really complex, the low level, and then they return something that's easy to consume at the high level.
Yeah.
Like they use that abstraction.
It's Chad level gas optimization.
Yeah, exactly, right? So like there's these different flags, right? So what you can do, like, and this is all bit shifting. This would definitely be a this would be super goofy, but yeah, so it's like it's 1 bit shifted left 1, right? So there's the flag, 1, 2, 3, 4, 5, 6, 7, 8, and then basically that's what the flag is going to look like for the skip NFT. And so what it does is it like takes all the flags, and then so this is super goofy, but there are going to be like 2 flags here, right? And then so it looks at the storage and figures out if there's a 1 here and a 1 here. And what this and does, basically it says is 0. What it does is it figures out if the skip NFT flag is turned on. If it's 0, then it's turned off, and then they use is 0 to flip it back to a Boolean. So that's like, you can comment this line and say like, is the flag set to on, right? And then
and then that's telling it which part of the slot to check of the 8-bit flags.
And so what this is saying is like, I think, so it is the flag set to on, and basically if this is saying if they have
if the flag storage variable also has it configured to on in that particular slot, like if the 6-0 is 1 or something.
It's like if they themselves have ever edited that storage slot. If they, okay, what it is if they've not ever touched, so okay, is the flag set to on? If I come to the contract, I've never set the flag to on. I've never said skip my NFT. If I haven't said skip NFT,
It's default.
and here, this is the important part. External code size is 0. Anyone want to take a crack at what this means? The owner?
Yeah, it checks if it's a EOA or a contract.
Exactly. Thanks, GPT. Is the owner a contract? So the functionality will be like this.
And why does that matter? Is because Ethereum accounts either have a code that's null or not, and that smart contracts will always have that populated part of the constructor.
Exactly.
Well, on construction and deployment.
So I'm going to turn off my Copilot here because it's being super annoying. My bad. But the logic that you can read this is like EOA's skip flag is false by default unless set. Smart contracts skip flag is true by default unless set. So why might this might be important? This is that DeFi composability thing.
Yeah, so it's. But it does not, its skip flag is set to true by default for contracts.
Mhm.
Why would they want that
Because they would
design?
mint the NFT to like the exchange, like the Uniswap pool.
That's exactly right.
Yeah,
Right.
like it could be that a contract could have any number of overrides on a transfer, and if a token ID is transferred into a contract that says, well, we actually don't allow transfers out from this contract, then essentially that token ID is being sent to a contract that is unrecoverable.
So if we go to, that's correct, and is uncontrollable. So we want to just disable that by default. So for example, if we go to the LP, okay, if we go to the liquidity pair address, so this is the Uniswap v2 pool. Notice it's holding 400 asterisk, right? But if we pop this address into like OpenSea to try to view how many NFTs this Uniswap pool has, you would think that, oh, this this Uniswap pool would have like so many, like 400 NFTs, but it holds no NFTs because it's a smart contract and therefore it's set to false. The skip NFT flag is set to true by default. So it can hold tokens, but not receive the NFT as a result. So kind of what we're learning here is as we're peeling this back, and kind of like what explains, bless you, some of this behavior of basically of OpenSea when we go to asterisk. We see that, dude, I just want to look at asterisk. We see that it has only 7,000 items. Like a lot of that is because when it's out, and it's fractionalized, but also when it's out in DeFi land in smart contract wallets, it's not actually being, they're not actually getting NFTs.
I went up, somebody bought more.
Hey, they're watching the stream. But yeah, see, look at this, right? Like there's a smart contract that holds a ton of these. Here's the Uniswap pool. This is a contract.
That we're looking at.
I'm not sure who has all these bags. I wouldn't be surprised if that's like one of the devs. But yeah, so like any of these contracts that hold tokens won't really be holding NFTs unless they explicitly themselves set their skip NFT flag to true. So if you're a Gnosis safe and you want to hold these as NFTs, you would have to make a call to this function, to this contract, where you say set skip NFT. Set skip
Yeah, I
NFT.
also noticed that that was not, the permissions on that are open. It's a public, with it's not only owner. There's no only owner modifier on this.
That's true, right? So I can set my set skip NFT because it's the message sender. So I set my, if we go to this function definition, it sets my owner account. It sets my set skip NFT to true.
That's interesting that it's also message sender. That means that a contract would have to literally like inherit from this contract or to call this or to expose it, or they would have to like write their own custom bespoke function that actually calls.
That's right. Or they're a Gnosis safe where they can, or a smart contract account where they can execute arbitrary logic.
Okay, interesting.
Yeah, so like smart contract accounts or Gnosis safes can like execute arbitrary logic once they kind of reach that parameter on behalf of themselves.
So it's an interesting design choice that they rolled out this skip flag, that they set defaults differently for EOAs and smart contracts.
Yeah.
And for a smart contract to not skip the NFT, they're actually creating kind of not an easy path to make that happen, to override that.
Yeah, like a smart contract both has to know about that and has to set it themselves.
And has to write it themselves, has to call it themselves, has to write some bespoke Solidity to be able to.
Right. So let's think about this though. Worst case scenario, if I'm maybe like the worst user experience is I have a smart contract account or I have a wallet, a smart contract wallet, and I buy a bunch of the ERC20s expecting to receive a 721. Remember, because if I buy the 721, I get the 721.
Yeah, right, okay, right.
Now, worst case scenario, I'm a Gnosis safe, or I use a Gnosis safe online, right? I buy 5 ERC20 tokens, and I expect to get 5 NFTs. I get 0 NFTs because I'm a smart contract. And you're like, what the heck? Worst case scenario, I as a Gnosis safe will have to set my set skip NFT function to true or to false. I have to say, hey, I want NFTs. I then transfer my balance to my EOA and then transfer the balance back from the EOA to the safe.
Seems like a pretty shitty DX.
Yeah, well, it's a bummer. It's a bummer of a UX, but it's like it's an edge case because a lot of us use EOAs. Right? Exactly. Okay, so that was a good little side quest. So the set skip NFT function, we went over that. We have transfer and we have mint and we have burn. We were going through mint. So this is what we expect. The to balance will be address balance plus the amount. Remember, this is amount of ERC20s. So here's what I'm gonna say. Storage, which I'll represent as like, I'll erase some of this stuff.
Just a heads up, it says 3 p.m. Just so we can check it.
Oh, it's 3 p.m. Yeah.
Just,
Okay. Perfect. Good to know. Yeah, let's go over this real quick. So, the storage of all the data on this contract, I'm going to use it as a $sign because they reference it as a $sign. The $sign storage value, all the storage for both tokens are kept in this one contract. So there's kind of a mind bender. So I'm just gonna kind of poke this further. When I read balance of on that NFT, it forwards the call to ask to read the ERC20 storage, it then returns the value, and then returns the value to the reader. When I say transfer, not only does it handle the transfers on both tokens, it also increments and decrements the amounts for both the NFT and for both the tokens. So there's just like, that's another concept, is it's unified storage. And so that's really why this is called a mirror. Is because it is just really, it's literally like a mirror where you're holding it up and you're like, there's like a spotlight, right? You're like holding it like this, you're just reflecting back whatever storage exists
Okay.
on the other contract. So when I look at this, I see this contract. So this is a really good mental model as a mirror.
I think of it like a proxy, right?
Yeah.
Proxy.
Yeah, it is like a proxy. You're exactly right.
Did you say it stores the balance of the token IDs?
To the mirror.
So, sorry. So like you could call like the mirror is the 721, right? No.
Yep, the mirror is the 721. Yep.
So
when I want to transfer my NFT, I go to the NFT and I say, hey, transfer token ID 21.
Yeah.
You want to see what happens? You want to see the
like
code?
it should be doing accounting on the 721 underlying, right? But this uniqueness of it doing accounting all in ERC20 is what makes it unique.
Going back to the very beginning,
Mm-hmm.
if we didn't have collisions between the spec of the ERC20 and 721, this could all exist in one contract, right? And it's split because of that initial collisions there.
I think you could probably do something like that. Yeah, it's to like, hey, like this is
Just forwarding clearly all the functionality can exist in one contract.
Right.
But we need to expose two different interfaces for it.
Yeah, that's true. I think that's probably right. So okay. Here we go. The transfer from contract. Remember, this is the mirror. This is the 721, and this is the last function we'll go over before everyone can kind of like break and leave if you need to, because it is late. And then we'll wrap up in a few. This contract goes deep, right? But at least I think you'll have a mental model to like buy this stuff / also like be dangerous if you wanted to, right? So,
We're gonna all launch collections today.
Exactly. And it's like approved, audited by Colin Nielsen. I mean, in a bunch of trouble. So what it does is it loads the base contract, the ERC20, right? So does this kind of track for everyone? It's like saying, hey, I'm the mirror. What's the base contract? It loads that from storage. This you can ignore. It cleans, you're probably familiar with this. This is cleaning the bits. So anything in when you use assembly, anything in memory is a 32 byte value. So when you shift something left 94 bytes, 96 bits, it will clean off the left side, and then you shift it right again, and then that puts it back in kind of a normal spot. So it cleans the bits of the to and the from. So like I said, you can totally ignore it. This is the transfer from signature, transfer from NFT. So it's the Solidity uses signatures, which
You could look that up. You know, there's like a code, EVM.codes maybe, or like not EVM codes.
it's a 4-byte directory.
That's right.
That's a good one. But also we could sanity check this too. We could come here. I like to use cast, which is a great command line tool that comes with Foundry. So you could use just sanity check. You could do cast kachak. That gives you the 32-byte hash of the signature. And if we just stick this guy right on top of here, we'll notice that it lines up, right? So that's a function selector is the first 4 bytes of any of the hash of the function signature. So we're saying, hey, this is the function we want to call, and then we store these. All these things are, what this is doing is this is storing up a long byte string in memory. This is storing up call data. So at this point, the call data should look like this, right? And then it's going to be a bunch of zeros, and then specifically 12 zeros, and then it's going to be maybe like, then it's going to look like the from address, and then a bunch of zeros, and then the to address, and then the ID. So like, say I pass 21, it's going to be a ton of zeros. So we could say cast bytes 0.
You had 256, right?
Yeah, hash 0. There, yep. So we're going to go 32. So what this will do is it'll take this, and then maybe I pass 21, so it'll be like 21, or quickly, if anyone can think what 21 in hex is, it should be 0xa4?
Go for it.
No, not A. It'll be 14. 0x14? 13? 14? It should be 6. It should be 20. 16 minus 21 is 5. 15. Okay. Okay, so it'll be 15, and then it'll be the address of the caller, right? So the message.caller is assembly for message.sender. So if I send this, then it will be like my address again, right? So I don't know if this like makes sense. What this is doing is it's building up call data in memory. So when you see mstore like this, it's building up call data in memory, and this call data should be ABI encoded so that it can be interpreted by the receiver. The ABI encoder will like parse this into like 32 byte chunks, right? And then, yeah, I didn't parse it into 32 byte chunks exactly. I was just kind of guessing, checking, but like the receiver of this call should be able to see this. Then remember, we read assembly from the inside out. So what it does is it calls, here's the parameters here, it calls with gas. So it forwards all the gas to the receiver is going to be the base contract. It forwards all the ETH sent, all the call value, and then it's going to, it says like, it takes basically the spot in memory. It's saying, hey, pass all the call data in offset and in size. It says like, hey, take, all this call data here and send it. That's what you're going to send to the next contract, and then store the return value here. And so that's that's what all this assembly does, and then it logs a transfer event, right? So we're sending a transfer from NFT event to the 404. So if we pop open the 404, I'm going to make this a little smaller. Hopefully it's still visible. So if we pop over the 404 on the right-hand side, it should call... yeah, this is fun. So this, this contract will look for the transfer from NFT function. And actually what will happen is it won't find it. See how there's no function signature that is public that says transfer from NFT.
Is that what the call data is actually trying to call?
Yep, that's what it'll
Yeah.
call. And so what will happen,
So how can it call an internal function through this fancy assembly packing?
well, so what they did is they added a fallback function. So look at this dev comment. Fallback functions are for calls from the mirror NFT contract. Stop. Okay, stop it. Ugh. Okay, fallback functions are for calls from the mirror NFT contract. Override this if you need to implement custom fallback with utilities. Dude, what's that guy doing with his bike? That's so annoying.
Yeah, I wonder what the modifier is that it runs.
Yeah, so this, it runs DN404 fallback. So it loads the function selector and then does its own function selector matching. So look, here's the transfer from NFT. So if it matches this, if the function selector, if we see this here,
It's trying to call transfer from.
exactly, if the function selector is this, which it will be, then, 8, then what it will do is it will, first it does this authorization control. It makes sure that the sender is the mirror contract. So it has this permissioned access control that allows it to talk back and forth to each other.
Yeah.
And then calls transfer from NFT with from to ID and message sender. And so this is now where we go. This is the actual function.
I don't think I've ever seen the permission fallback before. It's really cool.
Isn't that a cool pattern, right? Where it's like the external, the public functions are truly public for people to call, but the permissioned ones are in a fallback. It's a very interesting pattern. And it's kind of dangerous because Solidity builds that function. It builds that for you. At the beginning of every smart contract is what's called the head, where when you call a contract, it invokes the receiving contract's code. And so every Solidity contract, what you don't see is there's code that loads itself into memory, reads the call data, understands what function selectors it has, and then reverts if none match. And so like that's exactly what this fallback function, this like DN404 fallback function does. It checks, hey, if it's this, do this. If it's this, do this. If it's this, do this. And then it returns, and guess what it returns to? Otherwise, revert.
I think my favorite weird optimization rabbit hole is appending random values to your function name so it ends up at the top of that list.
Yes, that's a fun rabbit hole. You have gone deep, my friend. If you know, you know.
So it's optimizing like hitting those functions earlier in like the call data.
Yeah, because they have
Ahead.
because it's a hash, right? So look at this. The hash of the word link mirror contract starts with a 0. So it's therefore cheaper to execute because it's less bit-wise, it's less dense than something that starts with 2. This is a bigger number. This is a smaller number. So this is going to be more gas efficient to run and load into memory
It's the order.
than this will be.
I don't think the number of bits would matter because it's at the like word level. for each
Oh,
phrase.
yeah, you're so right. No, I'm wrong because it's the jump dest. Like if
Because it has to go in order of each of these. So it's like the most common function is the first one, then it did less operations on average.
oh, that's really interesting. Okay. Yeah, nice. Good call. Okay, so it's 314, 315.
To me, that is a lot of Solidity, and I would love to see the optimization, that packing it in that very crafty way, creative and crafty way, like yields.
Barely. Don't do that. Don't append random data to your functions.
Yeah,
Right,
yeah.
is it like a 0.0000001% increase in?
Yeah, I'm interested to see how much
It's like 300 gas, which is like not much money. It's like,
how much does padding the call data save, like in their mirror versus just having it do it for you?
so I get it's late and I cannot do this to myself. I promised myself I would not do this. But I really want to create, like what I would do is I would make a forge script and I would call a contract without assembly. And then I would call in another contract the exact same code but with assembly and see what the gas difference is and run a gas report. Because you can build that string in assembly directly and save some gas.
I wonder, also another thing here is that, like hashing collisions, especially with these like these function selectors and
Yeah.
for bytes, there's definitely often multiple function signatures that will yield the same cache, the same first 4 bytes of their hash.
Mm-hmm.
And so that definitely becomes a security concern for a lot of things, especially upgradable contracts. But along that same line of thought with security in mind, I wonder if they're just making an assumption here in their constructor that these hashes, these function signatures, like first, there's an invariant involved that they will exist on the contract.
That's not so much an invariant, but I get what you're saying. There's
You know what I
there's
mean.
an assumption.
Like they have to
Like-
okay, these 3 if checks. These
Really good to meet you,
signatures
Sian.
we have
Yeah,
in there,
take care. Thank you.
So you guys.
These are indeed
Bye.
functions on the contract.
Yeah.
But like that's I mean it's also a concern.
So, I think you're releasing both of these pieces of software in tandem. You have access control over both of them. They're meant to be released and co-joined. They're not they're not made to be interoperable with anything. So I think that's an okay assumption to make.
Right, I think it's an okay assumption. Yeah, I would have made the same choice. Like it's okay to plug these 3 hard-coded in because we know that these are the function signatures of 3 functions that exist in this contract, and we know that these are trying to be called.
Mm-hmm. Mm-hmm.
It's really not an issue, but just thinking it through to come to that conclusion.
Yeah.
It's not an issue.
Yeah.
I've seen other patterns like this. I think maybe the on ERC 721 received kind of has this like it's like only called through a fallback mechanism, a fallback modifier. I've seen this pattern before.
Interesting. Yeah. Yeah, fallbacks you can do really interesting stuff with. All right, for sure. Does anyone want to do a 3-minute side quest? We didn't use any of our side quests. You guys want to do a side quest with the gas comparison of loading call data directly versus? What do you guys think? Would you be interested or no? Because if not, no
I'm
worries.
just gonna go do it at home. Sorry. Don't let me derail.
Yeah, do it at home. Do it at home for sure. Because I want to see like how much gas it saves to do it in assembly versus to do it like.
Because it can't be a ton.
No, it can't. It can't.
It looks cool.
It does look cool, and it makes you feel cool, which is the more
That's
important part.
Very important.
Absolutely, the most important part.
Security by obscurity.
Yeah, security by street cred.
Street cred too, yeah. The more obscurity, the more you know, and the less they don't.
Yeah,
Just tell them there's like 2 days of interesting things for me to find in this contract.
dude, I know, and like these guys are so like, they're just like the best in the industry, right? So it's like.
So who are these? Who is this team? Who are they? 404. It kind of reminds me of the token bound account guys.
These are my friends actually.
They're
Token bound
Yeah.
org. Yeah.
they're the Gaslight team.
We work closely with them. The founder is an advisor of ours.
Yeah.
I actually gave a talk at the
that's
Token
not
Bound
the
Accounts
page.
during
They've been working.
this year.
Really?
So
I want to see it.
It's online.
The
Yeah.
404 has been up to 5 days.
And
yeah,
yeah.
Were you sweating?
Working on token
What do you mean?
Because your repo is outdated.
I was like, oh man.
You're like, come on.
Calls,
It's excellent.
calls,
Oh, you did?
No, I was working on the script. I got another contract now.
Yeah.
Nice.
Maybe we're probably in the same place. But just thought it was like really cool that they were like this home ragtag team.
No idea.
It's like putting together a PRC proposal and like really